This is section 7.2, application of Venn diagrams. So we're going to do several things with Venn diagrams, and one of the rules that we will use is this one right here. The number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in the intersection of those two. So we'll use that in a bit. Let's look at some examples. B intersect A prime. Well, remember, A prime is everything that's not in A. So here's A, and I colored everything that was not in A blue. So that was up to here, was everything blue. Then B, I colored yellow. So the intersection of those two things is the green part. This would be the solution. That's the intersection of B and everything that's not in A. B intersect the union of A prime intersect B prime. Well, that's kind of crazy. So this is the elements that are not in A and not in B. So if we did that first, what's in not in A and not in B, that would be this yellow. Okay? And then B prime is everything not in B. So that's the yellow and this part of A. So the total colored area is the answer. That's B prime with that intersection there. All right, this one has A intersect B, and then that thing intersect C. So if we have the three circles to start with, A intersect B, what's common to A and B? That would be this piece right here. And then when you intersect that piece with what's C, what's common in A, B, and C? It's just this piece here, right here. Okay? So it gives you an idea of how we're going to look at things. Let's go ahead and look at the problems. All right, number one, select the Venn diagram that represents the set below. So C intersect D prime. And what I find sometimes easier to do is to not look at all the choices, but rather just draw my own and see if I can figure it out. So D prime is everything not in D. Not in D. And D prime intersect C is what is common to both of those things. So if I took C and said, okay, I'm going to color in C with blue, the overlap there is what is our answer. So that green, see, we've got right there, so that's that. F prime union C. F prime union C. All right? So F prime is everything not in F. And then if we color in C, we've got that. So F prime union C would be all of this and the surrounding area. So that would be this right here, because this was F prime, and then C would pull in this much here. And so you would have all of this. Okay? U prime. Okay, if the universe, if you will, if that's there, U prime is everything not in U, which is the empty set. So A would indicate the empty set. Nothing is shaded. Three sets divide the universal set into at most how many regions? So what I did was draw the three sets, and you have this area, this area, this area, and then you have the 4, 5, 6, you have the 7 in the middle, and you have 8 out here. So it's at most 8 unions, 8 regions. Sketch a Venn diagram like the one shown to the right and use shading to show the set B intersect E prime and then union with H. So I did it in steps. So I did the first part. E prime is everything that's not in E, so that's in this yellow here. B intersect that means what is common to this and the circle B would be this piece right here. So I just have that now. If I take that and union with H, then H is this part here, so now I have all of here and this part of B. And so we can see that is view A. All right, we're doing the same thing here on number 6. All right, so the first thing I wrote down was E prime. That's everything not in E. And then I wanted to see this part right here. So A prime is everything not in A. And then F is all of this. So A prime union F just pulls in this part here. So I've got this. And now if I want to intersect that with E, that means what's common, what's the same in both of these. And you get all of the U part around, and then F right here, not counting this little piece here. That's the only pieces that are common to both of those. So that would be D. Now we're going to use the union rule to do some things. So here's the union rule. We said that at the first. If the number of A is at 11, number of B is 15, number of A intersect B is 5, what is the number of A union B? So we take 11 and add 15 minus 5. So that's 26 minus 5. Your answer is 21. Number 8, it gives you N of B, N of A intersect B, N of A union B. Now they want to know what's N of A. So you're having a different thing to solve for. This is the one that we don't know. Okay, so we know this is 15. We don't know this. This is 13 minus 4. So number of A plus 9. So I'm going to subtract the 9 just like an equation. So 6 is equal to the number of A. All right, so we're going to use the information to fill in the number of elements for each region in the diagram. So we are given that number of elements in A is 20, number of elements in B is 24. A intersect B, so that means what's common between these two is 16. And B prime, everything not in B, is 37. All right, so in place of X, what is this value here? It's 20 minus 16. That's that one. The number in place of Y, which is here, we were given that. A intersect B, so we were given that. Number in place of Z should be 8, and we can do that by 24 minus 16. That gives us that. The number in place of W. So what we want to think about, we were given B prime is 37. That's everything here. All right, B prime is 37. And X plus W, so this value here plus everything out here is going to give us B prime. So we use that little equation, and W should equal 33. All right, and this one, now you're not given these numbers, they're not in your picture, but I've added them. So A union B is 22. A intersect B is 2, so I could write the 2 here. The number in A is 5. Okay, so I know that this has to be 3 because 3 and 2 are going to make up that number of A. And the number of A prime union B prime is 46. All right, so A prime, everything not in A, is equal to the group 4, that's all of this, plus 17. So B prime is equal to 4 plus 3. If I add those two, I get group 4 plus 20. Okay, that's the union of A prime and B prime. Subtract 20 from the 46. We were given that this is 46. So if I substitute 46 there and subtract that, I get 26 is in region 4. That's going to be that answer there. The number of A union B is equal to, and here's our rule, so we knew that the number of A is 22, and we've got that the number of A is 5, the number of B we don't know for sure, minus 2. So 22 is equal to 3 plus the number of B, and we get that the number of B must be 19. Must be 19. So let's see what we've got here. Did I have anything else? I think not. All right, so there's 3 elements in region 1, 2 elements in 2. If this total of B is 19 and that was 2, then that must be 17 there, and we figured out 26 from right here in this equation. So I think we figured out all we needed in that. And that gets you a good experience with applications of Venn diagrams.